Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So in this video we solve the one more problem on belt drives. So in this problem he has given an engine shaft running at 240 rpm is required to drive a generator. So means what, the engine shaft will become a driver and the generator will become a driven member. So by means of a flat belt drive, pulley on engine shaft has 160 centimeter dia. So D1 has given 160 diameter. So now I have considered here the driver as our engine shaft and the driven member is the generator. So D1 is given 160 centimeter dia, that is the pulley which is mounted on the engine shaft is having a 160 centimeter dia. So I have taken in terms of meter, so it becomes 1.6 meter. Similarly, he has given for the generator, the pulley on the engine shaft has 160 centimeter dia and on the generator shaft has a 160 centimeter dia. So means what, there is a one more pulley which is mounted on the generator which is of having a diameter 60 centimeter. Now I have taken in terms of meter, this is our 0.6 meter. So he has given the engine shaft running at 240 rpm. So which means N1 is given, N1 is our 240 rpm. We have to find N2 here. At the end we have to determine the speed of the generator shaft in the following cases. We need to find out N2 value for these four conditions here. Now for the first one, neglecting thickness of the belt. By neglecting thickness of belt, so the velocity ratio is given by N2 by velocity ratio is given by N2 by N1 is equal to D1 by D2. So N2 is unknown, what that is we have to find here. So N1 is 240 rpm, N1 is equal to D1 by D2. So N2 is unknown, that what we have to find here. So N1 is 240 rpm. So the D1 is our 1.6 meter, D2 is our 0.6 meter here. Now we just cross multiply and simplify this. We are getting N2 is equal to around 640 rpm. That is the speed of a driven member by neglecting the thickness of the belt. Now the second thing, we have to find out the velocity ratio when the belt thickness is 6 mm is considered. So we will move on to the second one. By considering thickness of the belt, now second case is, so we have to find out the speed of a driven member by considering the thickness of the belt of 6 mm. So velocity ratio is given by N2 by N1 is equal to D1 by D2. This is the formula to calculate the velocity ratio by neglecting the thickness. If you have to consider the thickness, means we just take the thickness in the numerator as well as in the denominator. We have to take, means we have to add here. So N2 is unknown. So N1 is 640, sorry, N1 is our 240 rpm, that is equal to D1 is our 1.6 meter and thickness is 6 mm is given. We have to take in terms of meter. I'll take 6 into 10 power minus 3 meter by, so D2 is our 0.6 meter. Again in the denominator also we have to take the 6 into 10 power minus 3 meter. Now we just cross multiply and simplify this part. So we are getting the N2 is equal to we are getting the N2 is 636.04 rpm. This is the speed of a driven member when the thickness of the belt will be considering here, that is which is of a 6 mm. Now we just move on to the third part. Now we will move on to the third case by considering the thickness 6 mm and a slip of 3%. So N2 by N1 is equal to, so D1 by D2, standard formula. If thickness is considered, we will take the thickness both in the numerator and the denominator. Now again we have to consider the slip also into account here. So in that case we have to take 100 minus s by 100. So this is the formula to calculate the velocity ratio by when the thickness is considered and the slip has been given. Now here the n2 is unknown, so n1 becomes 240 rpm. So d1 is 1.6 plus thickness is nothing but 6 into 10 power minus 3 meter by d2 is our 0.6 plus t is nothing but 6 into 10 power minus 3 meter into 100 minus s is nothing but our slip, which is given 3%. So we have to take in terms of percentage here in place of s, that is the slip value, so by 100. So what we have to do here, we just simplify this numerator and the denominator first. We have to simplify this part, then we just multiply with this number, so that we can get at the end n2 as our. So that at the end when we simplify this, we are going to get the speed of a driven member is 616.9 rpm. Now we just move on to the fourth one, find out the velocity. So we have to find out the velocity here. So velocity is given by the v is equal to pi d1 n1 by 60. So that will be the meter per second. So this is a standard formula here, but the thing is what, when we consider the thickness of the belt, so we have to take v is equal to pi d1 plus t into n1 by 60. This is what we have to take the formula now when we are considering the thickness into account. Even we can take pi into d2 plus t into n2 by 60 also. So generally we will consider this part here, since the data has given for the d1 and n1 here. I will not consider this part, so only we have to consider this one only now, because the thickness is given. So v is equal to now pi into, so d1 is our 1.6 plus thickness is nothing but 6 into 10 power minus 3 by 60 and into 240 here rpm. So when we just simplify this, we are going to get the velocity v is equal to 20.18 meter per second. So this is what the solution for a given problem here. So by neglecting the thickness of the belt, so we are getting the n2 is equal to 640 rpm, but when we consider the thickness of the belt as 6 mm, we are getting the speed of a driven member is 636.04 rpm. Slightly the speed of the driven member is decreases because when we are considering the thickness. Now similarly the third one is by considering the thickness as a 6 mm and a slip of 3%. So we are getting a speed of a driven member is 616.9 rpm. Again it has been decreases now because there is a slip in the belt. Because of the slip in the belt, so the power transmission will be decreases. So we are going to get a speed of a driven member is also where compared to the previous one, it has been decreases. Now fourth one is what we have to find out the linear velocity by considering the thickness of the belt. So this is the formula to take the velocity, but the thing is what, when we are considering the thickness as well, so we have to take pi into d1 plus t into n1 by 60. So now we just substitute the values over here, and we are getting the velocity as 20.18 meter per second.